You can ask a large language model to write a complex Python script, and it will often generate perfect, executable code in seconds. But apply that same system to a real-world problem without checking its work, and that flawless execution suddenly shatters, leaving you with catastrophic mistakes. Right now, hospitals, law firms, and financial institutions are rushing to integrate these tools into their daily workflows. They are handing over high-stakes tasks to systems that speak with absolute confidence, even when their accuracy is dangerously compromised. That confident tone is exactly the problem. Because an AI produces language so fluently, it creates an illusion of competence. It sounds like a seasoned expert, so we naturally bypass our own critical verification and take its word as fact. To understand why a highly advanced system invents false realities, we have to look under the hood. We need to find the specific mechanical flaw responsible for generating these errors. If we want to safely harness this technology, we have to stop treating it like an infallible oracle and start confronting its structural vulnerabilities directly. This diagram breaks down exactly how these models generate text. They do not look up facts in a database or a digital filing cabinet. Instead, they run on a probabilistic engine called next token prediction, building sentences word by word through a series of branching pathways based purely on statistical likelihood. Because they rely entirely on probability, the engine will occasionally select a highly confident path that leads straight to entirely false information. This is what developers call a hallucination, a plausible-sounding fiction generated with complete certainty. In a professional setting, this looks like an AI generating a non-existent court case for a legal brief, complete with a fabricated judge and fake citations, or inventing a medical study that was never actually conducted. The system does this because it contains no internal mechanism to verify the truth. It is simply programmed to find structural patterns in language, making no distinction between a hard universal fact and a mathematically likely lie. Hallucinations are a built-in feature of a predictive engine. Trusting its outputs blindly is a mathematical liability. The mechanics are only half the problem. We must also look at the fuel. These models learn from massive, unfiltered datasets scraped from the internet, text that inherently carries all the deep-rooted biases and stereotypes present in society. This visual represents how those learned biases manifest in the AI's output. When used in sensitive areas like corporate hiring or financial lending, the historical data tips the scales, unfairly skewing results and actively amplifying cultural stereotypes. Then there is the risk of data leakage. If you feed proprietary trade secrets or personal health data into a public cloud model, that information might be logged, inspected, and even used to train future versions of the AI. The architecture is also vulnerable to direct infiltration through prompt injection. An attacker can craft adversarial inputs that trick the AI into ignoring its core safety instructions, allowing them to execute unauthorized actions or extract data. Because of its open-ended design, a large language model acts as a mirror reflecting our societal flaws and an unguarded door for malicious manipulation. We cannot rewrite the mathematical rules of next token prediction, but we can engineer rigid external systems to contain its flaws. This diagram outlines the primary defense against hallucinations: retrieval-augmented generation. It forces the AI to pull context from a verified vault. Developers also use temperature control. Dialing it to 0 strips away creative variance, restricting the model to a single, predictable pathway. To neutralize security threats like prompt injection and data leakage, organizations apply strict input filtering, deploy private cloud instances, isolating proprietary data from public networks. This is the new standard for enterprise integration. You take a brilliantly flawed reasoning engine and surround it with rigid technical boundaries and cryptographic verification protocols. Even with advanced technical guardrails in place, the ultimate defense mechanism remains exactly the same for both individuals and large organizations: mandatory human oversight. Users must treat all AI outputs as rough drafts. They require expert human review, cross-checking, and validation. They are tools for acceleration, never authorities. By explicitly acknowledging these limitations and intentionally designing systems to guard against them, we can safely unlock the immense practical value of this technology. Thank you for exploring AI with Knowledge Equity Partners. Please subscribe and share. Next time, we'll look at the future of large language models.